Okay, so this is your week 5 of the ELP. Should be your last assignment to get you ready for pre-calculus. So we're going to start with a review. I know last week for graphing, I reviewed the unit circle, but we're going to start with reviewing one of your special angles quizzes from earlier in the year because you really need to understand evaluating special angles in order to get inverse trig. Okay, so as you can see, this is an actual quiz, the third quiz that you guys took. So again, go back and review your unit circle. If you are not feeling great about that, it's important. So let's look at this. Cosine of 4 pi over 3. So some of the patterns from the unit circle, if the numerator is 1 more than the denominator, I automatically know this is in the third quadrant. You always draw your triangle from the origin and then perpendicular to the x-axis. Your angle is always up there by the origin. And that's important because anything with a denominator of 3 has an ordered pair of 1/2 comma square root of 3 over 2. But in the third quadrant, you go left and down, which would make it negative 1/2 negative square root of 3 over 2. Then remember that your ordered pairs for special angles, the x-coordinate is always going to be cosine, the y-coordinate is always going to be sine. We're looking for the cosine, therefore my answer here is negative 1/2. Okay, so cosecant 5 pi over 6. Numerator is 1 more than the denominator. That tells me that the angle falls in the second quadrant. Again, diagonal from the origin, perpendicular to the x-axis, angle by the origin. Any of your special angles with a denominator of 6 have the ordered pair square root of 3 over 2, comma 1/2. In the second quadrant, you go left and up, which makes the x-coordinate negative. So remember again, the ordered pair is cosine, comma sine. Cosecant is the reciprocal of the sine. So if I need the cosecant, I need the reciprocal of the y-coordinate, which in this case would be 2. Number 3, numerator is 1 more than the denominator. Draw your triangle in the third quadrant. Denominator on your radian is 6. So that's square root of 3 over 2, comma 1/2. Third quadrant, you go left, you go down. Sine is the y-coordinate, so your answer is negative 1/2. Number 4, 3 pi over 2. That is not in a quadrant. That is one of your axis angles. It is the negative y-axis, so no triangle. You just plot it on the negative y-axis. The ordered pair, because the unit circle has a radius of 1, is 0, comma negative 1. Cosecant is the reciprocal of sine. Sine is the y-coordinate, so we need the reciprocal of the y-coordinate, and the reciprocal of negative 1 is still negative 1. Number 5, 5 pi over 3. So the numerator is twice the denominator minus 1. That puts it in the fourth quadrant. Denominator of your special angle is 3. That makes it 1/2 square root of 3 over 2 for your ordered pair. In the fourth quadrant, you go right and down, which makes the y-coordinate negative. Cotangent is the reciprocal of tangent. So tangent is sine divided by cosine, or y divided by x. So that would make cotangent x divided by y. So we have 1/2 divided by negative square root of 3 over 2. The 2's will cancel out, so end up with negative 1 over the square root of 3. Secant of 2 pi over 3. Numerator is 1 less than the denominator. That puts your triangle in the second quadrant. Denominator of your special angle is 3. So it's 1/2, comma, square root of 3 over 2. Second quadrant, you go left and up. That makes the 1/2 negative. Secant is the reciprocal of cosine. Cosine is the x-coordinate. So we need the reciprocal of negative 1/2, which is negative 2. Tangent of pi. Pi is another axis angle. It's right here, no triangle. The ordered pair is negative 1, comma 0. Tangent is sine divided by cosine, or y divided by x. So 0 divided by negative 1. 0 divided by anything is 0. If 0 is under the line, it's undefined, but 0 divided by anything is 0. 11 pi over 6. The numerator is twice the denominator minus 1, so the triangle is in the fourth quadrant. Denominator of the special angle is 6, so it's square root of 3 over 2, comma 1/2. In the fourth quadrant, you go right and down. That makes the 1/2 negative. Tangent is sine divided by cosine, or the y-coordinate divided by the x-coordinate. And again, the 2's would reduce out, and my answer is negative 1 over square root of 3. Cosine of 7 pi over 4, that's also in the fourth quadrant. Numerator is twice the denominator minus 1. So I think this is the first angle on here that's got a denominator of 4. That goes with your 45-degree reference angles. The ordered pair is 1 over square root of 2, 1 over square root of 2. In the fourth quadrant, right and down, that makes this negative, and cosine is just the x-coordinate. And the last one, the secant of 3 pi over 4. So numerator is 1 less than the denominator. Draw your triangle in the second quadrant. Again, when the denominator is 4, it's 1 over root 2, 1 over root 2. Second quadrant is left and up. Secant is the reciprocal of cosine. Cosine is the x-coordinate. So I need the reciprocal of negative 1 over square root of 2, which is negative square root of 2. Okay, so that is your review of special angles. Again, the better you know your unit circle and the better you're able to evaluate your special angles in a unit circle, the easier inverse trig will be to understand. So let's go over the notes that you were given. So this basically is something I prepared for a time when I needed to be able for students to be able to read it and understand it if I wasn't standing right in front of them. Okay, so I'm just looking at it and seeing some things that didn't print out quite properly. Okay, inverse trig is just special angles backwards. That is the foundation of inverse trig right here. The better you know special angles, the easier inverse trig is. So for example, this should say the sine of pi over 4. Okay, so instead of pi, there's a p there. I don't know why I printed out like that. The sine of pi over 4 would be 1 over root 2. But as an inverse trig problem, instead of sine of the angle equals the value, we do the inverse sine of the value equals the angle. So it's got all the same information. It's just that instead of giving you the angle with a trig function and you tell me the value, we give you the inverse trig function and the value, and you come up with the angle. So it's special angles backwards. So a typical inverse trig problem would look like this: the inverse cosine of square root of 3 over 2. So again, the inverse trig function and then a typical value for special angles. So what you would need to do is think about the information that you know from the unit circle that helps you evaluate special angles. To solve this, you want to relate the trig function to the ordered pair. So cosine is the x-coordinate. So basically, they have given me, when they gave me this statement, they gave me the information that the x-coordinate is square root of 3 over 2. Well, there's only 7 ordered pairs I'm supposed to know. And so the only thing the y-coordinate could be is 1/2. And then I just have to figure out, okay, well, if that's the ordered pair, what angle gives me that ordered pair? And that's my answer. Pi over 6 is the angle that gives me that ordered pair. So that's going to be the easiest for sine or cosine, because cosine x-coordinate, sine y-coordinate. It gets a little harder when the function is not sine or cosine, because you have to think beyond just the simple x-coordinate and y-coordinate of the ordered pair. So here's an easy example. If it's secant or cosecant, then it's not that much harder. So if I had the secant, inverse secant of 2, so I would think, okay, well, secant is the reciprocal of cosine. So we're dealing with the x-coordinate, right? Because cosine and secant relate to the x-coordinate. So if secant is the reciprocal of cosine and we're dealing with the x-coordinate, then we must know that the x-coordinate is the reciprocal of 2, which is 1/2. And then the only thing that the y-coordinate can be is square root of 3 over 2. Because again, there's only 7 ordered pairs, and the only one that has an x-coordinate of 1/2 has a y-coordinate of square root of 3 over 2. So what angle gives me that ordered pair? The answer, I get that ordered pair from an angle of pi over 3. It would be helpful if you were familiar with the result of special angles for trig functions other than sine and cosine. So like for tangent and cotangent, you have to take, for tangent, the sine divided by the cosine, or the y-coordinate divided by the x-coordinate. So the more familiar you are with those scenarios, the easier it's going to be to think of the right angle. So if I'm given a tangent value of 1 over square root of 3, well, that comes from 1/2 divided by the square root of 3 over 2. And it's the y-coordinate divided by the x-coordinate. So I would know that that comes from an ordered pair square root of 3 over 2, comma 1/2. If the tangent value was square root of 3, again, sine divided by cosine, or y divided by x, that ordered pair would have had to been 1/2, comma square root of 3 over 2. And if I got a tangent value of 1, well, from my 7 ordered pairs, the only way that would happen is if I divided something by itself. So the ordered pair must be 1 over root 2, 1 over root 2. That's the only possibility. All right, so since tangent is sine divided by cosine, you need to relate the above values to both coordinates of the ordered pair, as we just talked about. So if I was given inverse tangent of square root of 3, well, looking up here, that would only happen if I had square root of 3 over 2 divided by 1/2. So this must be the ordered pair, and this ordered pair comes from a special angle value of pi over 3. Okay, so that's the thought process that you need to go through for inverse trig. But it gets a little bit more complicated than that. Okay, so let's consider when the inverse involves a negative value, right? Because there's 4 quadrants and, 2 pi radians in a unit circle. So it's not always in the first quadrant. Every trig function has 2 quadrants that give a positive special angle value and 2 quadrants that give a negative special angle value. For example, sine is positive in the first and the second quadrant because those quadrants where the y-coordinate is positive. Tangent is positive in the first and the third quadrant because in the third quadrant, you'd be doing a negative divided by a negative for tangent. And then cosine is positive in the first and the fourth quadrants because in the fourth quadrant, then the x-coordinate is positive. So they're all positive in the first quadrant. So for example, sine is positive in the first and the second. So if the answer to our inverse problem is pi over 4, it could also be 3 pi over 4 because that's the first quadrant angle and the second quadrant angle, since both of those angles will give you a positive value of 1 over square root of 2. So we have a restricted domain for inverse trig. Basically, that means that we're only going to have one right answer. So instead of the answer being able to be pi over 4 and 3 pi over 4, if I have an inverse sign with a value of 1 over square root of 2, I'm only going to have one right answer. So for every one of the trig functions, we're going to have one positive quadrant and one negative quadrant. Okay, so it's going to be the same for sine and tangent. You want the 2 quadrants, you want one positive quadrant, one negative quadrant. You want those quadrants to be right next to each other. So for sine and tangent, remember all of the trig functions are positive in the first quadrant. And for sine, I can't use the first and the second quadrant because it's also positive here. And I want the 2 quadrants to be next to each other. So sine is negative here. You have one positive quadrant, one negative quadrant, and they're right next to each other. And when we get into pre-calculus, we're going to go all through the graphing of the inverse of the trig functions. And there's a specific reason that we do the same thing for tangent. But for this moment in time, just remember that the restricted domain for sine and tangent is the same, and it's restricted to the first and the fourth quadrant. Okay, the first for your positive values and the fourth for your negative values. Then cosine, we can't use the first and the fourth because remember, cosine has a positive value in the fourth quadrant as well because the x-coordinates are positive down here. So for cosine, we have to have a different rule, positive in the first quadrant, and cosine is negative in the second quadrant because the x-coordinate would be negative here because we go left. So cosine restricted to the first and the second quadrants. Okay, and then of course, cosecant and cotangent would be the same for sine and tangent, and secant would be the same for cosine. Okay, so that's important because you want to answer with just the one right angle from the correct quadrant. It should be easy if the value given is positive because you're just going to answer with the first quadrant angle. But if the value given is negative, if it's cosine or secant, your angle has to be in the second quadrant, which is what you're used to. What's going to be different, though, is for sine, tangent, cosecant, or cotangent, if the value you're given is negative, instead of doing our normal fourth quadrant angle, for example, 11 pi over 6, instead we just say negative pi over 6. We can only swing back and forth this way. So to get it to 11 pi over 6, we'd have to go all the way around the unit circle to get to the fourth quadrant, but we're not allowed over here. This is a restricted area. We're only allowed here. So if it was 11 pi over 6, we would instead just say negative pi over 6 because that means we'd still start here, but we would go clockwise to get to a negative 11 instead of 11 pi over 6, negative pi over 6, and that would keep us in the allowed area. So here's some examples. If the inverse sine has a value of negative 1/2, remember it's sine, so that means that the y coordinate is negative 1/2. So that would mean that your ordered pair would have to have a y coordinate of negative 1/2. So your x coordinate then would be square root of 3 over 2. And normally for that, we would say 11 pi over 6, but because, again, 11 pi over 6 would make us rotate into quadrants we're not allowed in, instead we're going to say negative pi over 6, moving clockwise, and that would be our answer. So what if the cosine value is negative? So cosine is an x coordinate, so the x coordinate must be negative 1/2. We then know that the y coordinate would be square root of 3 over 2. And so if cosine's negative, we're going to do what we're used to. We're going to put it in the second quadrant, and we would answer with 2 pi over 3. If the tangent is negative 1, so we talked about, how do you get these tangent values from your ordered pairs when you do the y divided by x. So if you're going to get a value of 1 or negative 1, it's going to come from 1 over root 2, 1 over root 2. Tangent is restricted to either the first quadrant or the fourth quadrant, and since the value is negative, it must be the fourth quadrant, which would make this negative. And instead of saying 7 pi over 4, which would make you rotate into forbidden quadrants, we're going to just rotate clockwise and say negative pi over 4. So for sine, cosine, cosecant, sine, tangent, cosecant, cotangent, if the value given is negative, answer as if it was positive, but then just put a negative on your angle that you come up with. All right, so sometimes you have a little bit more difficult problem like this one. What is the sine of the inverse cosine that has a value of 1? You just want to work from the inside out. So the inside is what angle has a cosine value of 1? That's what that is asking. What angle has a cosine value of 1? Well, if the cosine value is 1, then the x-coordinate is 1. The only thing the y-coordinate can be is 0. And that ordered pair you get from right here on the unit circle. So that's 0 radians. Okay, so the angle whose cosine value is 1 is 0. Then I would just replace this part of the problem with 0, and now it becomes the sine of 0. That's a special angle problem. You should be pretty good at that. What is the sine of 0? Now that's saying that the y-coordinate is 0, which makes the x-coordinate 1, and the angle whose sine has a value of 0 is still 0 radians. So the answer is still 0, even though that's what we came up with for just the middle part. All right, let's try another one. So for this one, the inverse sine of the tangent of pi over 4. So we'd start with the inside part, which would be tangent of pi over 4. And the tangent of pi over 4 would be 1. So now we just need the inverse sine of 1 right here. So what is the angle that has a sine value of 1? Again, sine is the y-coordinate. The x-coordinate would have to be 0. The angle that gives us that ordered pair is pi over 2. Okay, so far we pretty much just raised the trig function to the -1 power to indicate it was an inverse problem. You also have this other notation, which is you put the word arc in front of the trig function. So you're going to see it either way, either the trig function raised to the -1 power or arc in front of the trig function. Both of those mean inverse trig. Some shortcuts. The sign of the inverse sign, they just undo each other. It's like having a square and a square root. Cosine of the inverse cosine, tangent of the inverse cosine. So if you have a regular trig function and it's an inverse, they just undo each other, and whatever that value you're given is your answer. Also, if they were reciprocals, so let's say I had the sine of the inverse cosecant of x. So since these are a regular trig function and an inverse trig function, but they are reciprocals of each other, then my answer would be the reciprocal of x. Okay, so those are just some other things that come up that are shortcuts. Okay, so what I'm going to do now is just give you some examples to help you with your practice and your assignment for this week. So all I've done is take right here, these were the 10 special angle problems from this quiz we used to review. Okay, so we've already been through these 10. And so that's what these are listed down here. Okay, and I'm just going to take those and rewrite those as special angle problems. From special angle problems to inverse problems. Okay, so instead of a special angle problem saying the cosine of 4 pi over 3, okay, first of all, it wouldn't say 4 pi over 3 if it was an inverse problem because we have our restrictions. But the answer to this was -1/2. So the inverse trig problem would say the inverse cosine of -1/2, and we would come up with the angle. So remember, cosine is restricted to the first and the second quadrant. So our answer could not be 4 pi over 3 because that's in the third quadrant, and that's not one of the two quadrants that we would use. So if the cosine value is negative, we want our angle to be on the second quadrant. So instead of 4 pi over 3, we would answer with 2 pi over 3. Instead of a trig problem, a special angle problem being cosecant of 5 pi over 6. So we answered that before. The cosecant of 5 pi over 6 was 2. Okay, we got the ordered pair, and the sine was 1/2, so the cosecant was 2. So what angle would give us a cosecant value of 2? Okay, so remember, cosecant is just the reciprocal of sine, and sine and tangent are restricted to the first and the fourth quadrant, which means that's true for cosecant and cotangent. And so instead of 5 pi over 6, if it's positive, we would choose the angle from the first quadrant, and we would answer with pi over 6. Okay. For a special angle problem, both pi over 6 and 5 pi over 6 have a cosecant value of 2, but for inverse trig, you only answer from the two allowed quadrants. And 5 pi over 6 would not be one of those quadrants. Second quadrant is not used for cosecant. Okay, instead of sine of 7 pi over 6, and we did that before, we came up with an answer of -1/2. So the inverse trig problem is what angle gives us a sine value of -1/2. Okay, again, we have these restricted domains. So if the sine value is negative, we want our answer to be from the fourth quadrant. So we know that it comes from a pi over 6 angle. We want that angle to be in the fourth quadrant, but instead of doing 11 pi over 6, we're going to answer with -pi over 6 because 11 pi over 6 would take us through two quadrants that we're not allowed to be in. So we can only rotate from the positive x-axis up to the y-axis or down to the negative y-axis. So number 4 was cosecant of 3 pi over 2. Okay, remember that 3 pi over 2 is right here. The ordered pair was 0, -1. Cosecant's the reciprocal of sine. So the reciprocal of -1 was -1. So the answer to this problem was -1. So the inverse trig problem would be, remember, we can also say arc instead of raising it to -1. So this still just means inverse. So what is the angle whose cosecant is -1? All right, so again, we've got these restrictions for sine, cosecant, tangent, or cotangent. So we can't say 3 pi over 2 because to get to 3 pi over 2, we have to go through quadrants 2 and 3. So instead, we need to go clockwise and say negative pi over 2. Instead of a special angle problem saying the cotangent of 5 pi over 3, the value or the answer to this was negative 1 over square root of 3. Okay, so the angle whose cotangent gives us that value is going to be a pi over 3 angle, but we have these restrictions. If the tangent or cotangent value is negative, the angle has to come from the fourth quadrant. That's it. That's all the choice we have. So instead of 5 pi over 3, we would just say negative pi over 3 because 5 pi over 3 would take us to the second and the third quadrant, which we are not allowed to be in for sine, tangent, cosecant, and cotangent. Okay. Instead of the special angle problem being secant of 2 pi over 3, and when we answered that, we came up with an answer of negative 2. The inverse trig problem was tell me the angle whose secant is negative 2. Okay, so remember this ordered pair, it was negative 1/2 square root of 3 over 2, and we took the reciprocal of the cosine. That's how we got the negative 2. So we know that this is the angle that gives us a secant value of negative 2. So the way we would work backwards is we'd say, okay, the secant value is negative 2, so that means the cosine is negative 1/2, which is the x-coordinate. So that would have to be the y-coordinate. And that's how we'd come up with the angle. For cosine, remember, you can be in the first or second quadrant, and so we can answer with just 2 pi over 3 that's in the second quadrant. If secant or cosine has a negative value, your angle should be a second quadrant angle. Okay, so the special angle question was tangent of pi. Our inverse trig would be what angle gives us a tangent of 0. Okay, so if you go through all your 7 ordered pairs, you can get a tangent value of 0 if you have 0 divided by 1 or 0 divided by negative 1, right? That's it. So the ordered pair would have to be 1 comma 0 or negative 1 comma 0. But because of these restrictions for tangent, it can't be negative 1 comma 0. Okay, that's not part of the restricted domain for tangent. So we would have to know that a tangent value of 0 would only come from this ordered pair, and then that ordered pair, instead of pi, we would answer with 0 because the angle of pi can't be used for inverse tangent problems. Okay, so instead of number 8 being tangent 11 pi over 6, when we answered that, we came up with negative 1 over square root of 3. And so the inverse trig problem would be tell me the angle whose tangent is negative 1 over square root of 3. So your thought process would have to go backwards to come up with the ordered pair and then the angle. So if you go through all your 7 ordered pairs, the only one that you can get 1 over the square root of 3 when you divide the sine divided by the cosine would be the square root of 3 over 2 comma 1/2. So if you get a tangent value of 1 over square root of 3 or negative 1 over square root of 3, it has to be from this ordered pair. But if the tangent is negative for inverses, it has to be in the fourth quadrant, which means that the y-coordinate has to be negative. So I know that's the right ordered pair. And then I would have my angle come from the fourth quadrant, but instead of writing 11 pi over 6, it would be negative pi over 6. Okay, so cosine of 7 pi over 4, we came up with the ordered pair and decided that our answer was 1 over square root of 2. So now we're just going to work in reverse. The inverse cosine of 1 over square root of 2. What angle gives me a cosine value of 1 over square root of 2? Well, cosine is the x-coordinate. If the x-coordinate is 1 over square root of 2, then the y-coordinate must be 1 over square root of 2. And if it's cosine and it's positive, we want our angle to come from the first quadrant. So instead of answering with 7 pi over 4, we'd answer with pi over 4. And lastly, our last special angle problem on the quiz was secant of 3 pi over 4. So we came up with an ordered pair, and we got an answer of negative square root of 2. Let's work backwards. If the inverse secant is negative square root of 2, well, we know secant goes with cosine, And so the x-coordinate must be the reciprocal of negative square root of 2, which is negative 1 over square root of 2. And if that's the x-coordinate, we know the y-coordinate's got to be 1 over square root of 2. And so we can reconstruct the ordered pair and then name which angle gives us that ordered pair. And so one more time, cosine and secant, we can use the first and the second quadrant. If it's a negative value, you want your angle to be in the second quadrant. So it would be 3 pi over 4. Okay, so you should be able to use that to work on the practice problems that you were given in the module. The answers are available. It's got some of those shortcuts in there where you have the sine and the inverse sine that undo each other. Remember, if there's more than one trig function, and work from the inside out. So you have the practice problems. And then here is your assignment. So if it's one inverse trig problem and a value, your answer should be an angle in one of the allowed quadrants. If there is more than one trig function involved, then you work from the inside out. So for here, the answer to the inverse part would be an angle, and then you'd be finding the cosine of that angle, and so your answer would end up being a value. It ends up being a special angle problem. So for 5 and 8, I can see that we've got 3 8s and 2 9s. Obviously, those are not special angle values, but these both have shortcuts because you've got the same trig function and reciprocal trig functions. Okay, office hours are the same this week. There is a new Zoom link that has password embedded in the ELP folder. So if you are having any problems on this assignment, please log in during one of the office hours.